right, we are back. We're going to continue, and every single time before I start the problem, I'm going to try to bring a little bit of a review for future problems from the lecture. Okay, so before we start problem number 3, okay, wow, we are only at 3, I would like to talk about the space interval between two events. So the space interval between two events. So when you went over the lecture, you saw that there is a formula that looks like this: s squared equals c squared times delta t squared minus delta x squared. Okay, so the space interval between the two events is this s right here. Let's kind of highlight it. That's the one. And what is important about this is that it has the same value in all inertial reference frames. So it's an invariant, okay? Just like the speed of light. Remember that. Next problem has to do with invariance, okay? So has the same value in all, I'm going to triple underline that, inertial frames. All right. So that is called an invariant. Just like the speed of light. Refresh your memory there, okay? Just like the speed of light. All right. Very good. Now let's look at problem number 3. So you have a starship that blasts past the Earth at 2 times 10 to the 8 meters per second. Just after passing the Earth, it fires a laser beam out the back of the starship. So this is quite interesting. You can actually make a drawing if you want to show something there. So let's say here's Earth. So the starship kind of comes and goes by, right? And so here's your starship, okay? Something like that. It passes the Earth with this velocity v. And just after passing the Earth, I'm going to make another picture right here. So say just after, so I'm going to say it's passing the Earth somewhere here. Let me make it a little bit better, right? So somewhere here is the end of that, of the starship, okay? And it's still continuing its movement with a velocity v. Now it's firing up a laser, and this laser, just passing it, it's firing up out of the back of the starship. There it is, v laser, let's say. All right. So with what speed does the laser beam approach the Earth? So the question is, what's happening here? How would you think about this problem? So take a moment and try to ask that yourself. How would you answer this question based on what I just kind of said above here? So you can pause the video and think about it. All right, well, let's talk about it. You are assuming that you have two systems of reference here, right? One is the Earth and one is the starship. And so each one of those are inertial reference frames, okay? But it was found, if you remember, that the speed of light is 3 times 10 to the 8 meters per second, and the number is not as important right now, but it's the same in all inertial frames. So this is one of those semi-conceptual problems that you will have to, yes, you can refer to that theory a little bit. So regardless of how the reference frames are moving with respect to each other, this is so regardless of how the reference frames are moving with respect to each other. All right. Well, with that being said, then an observer on Earth will measure the laser beam at the speed of light. So there's nothing to solve here. So C is constant, measured from Earth, and it will be same as 3 times 10 to the 8 meters per second. Okay, so that is all about this problem. I'm gonna stop this video now.